talking about here. So without graphing, how would I locate the vertex in this? Starting
Negative B over 2.
opposite of b over 2a. So my b is 6. I get the opposite of 6 over 2a is negative 3. And we get 1. Then how do you find the y?
Plug in 0.
Plug it in. And we get 4. So my vertex is the order pair 1, 4. What's the axis of symmetry?
X equals 1.
X equals 1. Okay. Does this parabola open up or down?
Down.
Down. How do you know that?
The negative.
The negative. You just look at the a term, so the squared. If it's positive, it's opening up. If it's a negative, that would flip it and it opens down. Okay, do you guys remember that part from yesterday? Do we need to do B and C? I just want to refresh. We've seen this before this year, talking about the discriminant. It's going to come up periodically, so whenever I get a chance to remind you what it is, I want to do so. That would tell us how many solutions a quadratic equation has. Remember I told you it came from the quadratic formula? If you have this, that piece under the radical determined what our solutions look like. If it was positive, we got 2 real solutions, because you would have something plus that square root and something minus. If it was a negative under the square root, what happened? There were 2 imaginary solutions. If it were 0, the square root of 0 is just 0, so all you'd be left with the opposite of b over 2a, and we just got 1 solution. So just to remind ourselves, if I just ask how many solutions will it have, you could just quickly do the b squared minus 4ac. If it's greater than 0, that's 2 real solutions. In terms of a graph, when I say the solutions, if you were looking at a graph, what am I talking about? Where it crosses the x-axis, yeah. So, for instance, it would be something like this. 2 solutions. It touches the x-axis. If it equals 0, you get 1 real solution. Okay, in other words, if you were looking at a graph, you have a quadratic that only touches the x-axis 1 time. If it is negative, you have 2 imaginary solutions. What does that look like on a graph? Can we graph imaginary solutions? If they're imaginary, how many real do you have? None. So it's just a quadratic that never touches the x-axis. Okay, and those are the only possibilities. It can touch the axis 0, 1, or 2 times. And we can determine that either by graphing or looking at the discriminant b squared minus 4ac like we did in the past. Let's look at a problem in our book real quick. Look at page 314. You don't have your share course next to you. They're nice enough to let you look at the book. We're just going to look at the odd problems here. So it says, exercises 41 to 46 show scatter diagrams of sets of data. In each case, tell whether a linear or quadratic model is appropriate. If it's linear, decide if the slope should be positive or negative. If it's quadratic, decide whether the mean coefficient should be positive or negative. So 41, we've got this kind of thing. So is that linear or quadratic? Quadratic. Would it need a positive or negative term? Have to be a negative 43, is that linear or quadratic? Quadratic. It's opening up, so it has to have a positive square term. 45, linear or quadratic? Linear. Okay, is that slope positive or negative? Positive, because it's increasing. Okay, so you guys can tell the difference from scatter plots there, linear or quadratic. Get an idea if it opens up or down. The last thing we're going to talk about is just a couple word problems here. So you may want a graphing calculator for some of this. That would be very confusing. Okay. Sometimes I may just ask you for a maximum or minimum point, and that is the vertex. And we have that nice opposite of b over 2a formula to find your vertex. We are going to sometimes be talking about height of an object, and we will be using this equation, so you need to write that down. I think I left that blank on your sheet. This comes from physics, so if you've had a physics class, you might have seen this equation before. V sub 0 represents your initial or your beginning velocity here. H sub 0 is your initial or beginning height. T is time measured in seconds, and the S of t is our height at a given time. Yeah, we did very simple versions last year. Oh, you think so? Put me in a bad mood right before I sign homework. Just saying. All right, let's look at one. So a ball is thrown directly upward from an initial height of 75 feet with an initial velocity of 112 feet per second. So we are going to be using this height function that I just gave you. So part A, give a function that describes the height of the ball in terms of time t. So when I say that, S and t are going to stay, but you have to replace the v sub 0 and h sub 0. What did I tell you v sub 0 represented?
The initial velocity.
Initial velocity. What was the initial velocity in this problem? 112. Plus h sub 0. What did I tell you h sub 0 was? Initial height, which was 75. So in part A, you just have to plug in for those two variables. Part B. After how many seconds does projectile reach its maximum height? And what is maximum height? Okay, we have two options for getting this. We can graph it and look at the calculator. We can also do a quick calculation on our calculator. When I'm asking you for a maximum or minimum, what am I asking you for? The vertex. This is a quadratic. Is it opening up or down? Down, because it's negative. So I know it's going to look like this. So here is my maximum. That's our vertex. Do we know how to quickly find the vertex? Absolutely. Opposite of b over 2a. So I get negative 112 over 2 times negative 16. That gives me 3.5. And then what do I need to do with that? Plug it in. So that answered the first question. After how many seconds do we reach its maximum height? It's after 3.5 seconds. What is the maximum height? Height is the y, so you have to plug the 3.5 in. And I get 271 feet.
You put the height in just
For the t. question, Bryce?
No.
So you guys all know how we got the time when you have your maximum and what the maximum is?
Wait, how did you get the 220?
I took my 3.5 and plugged it in for t in my equation.
Oh, I just plugged it in.
Mm-hmm. Just put it in the calculator. Let's see. For what interval of time is the height of the ball greater than 200? This is one that we probably don't want to do by hand. It's a little long. So we are going to use our graphing calculator here. I'm going to show you some tricks on your calculators. Right, you need to go to y equals. If there's a function already there, clear it out. And I'm going to enter my equation, negative 16. You just have to use x for your t, x squared plus 112x plus 75. Okay, just so all of us are kind of resetting our calculators to the same thing, if you go zoom number 6, that will reset us so we're all looking at the same window, negative 10 to 10. So zoom number 6. Is that showing me very much here? No. Okay, we are going to have to adjust some things. Let's go back to my y equals for a second. I want to know when the height is greater than what? 200. I'm going to go to my y2, and I'm going to go ahead and just hit 200. Now let's go to our window. We're going to have to reset this. X is representing time. Could you have a negative time? No, so I'm just going to go from 0 to 10. My y's, are we going to have a negative height here? We could leave it at negative 10. You could move it if you wanted. But what I really need to change is my y max. I'm trying to find when this height hits what? 200. So I've got to be bigger than that. We already know that the maximum was 271 from the previous one. So maybe I'm going to go to 275. Underneath that you have YSCL. That's your scale. It's what it's counting by. I'm just going to switch that to 10 just to help speed up my calculator a little bit. And then let's hit graph and see if we get what we need. So there is my parabola. And there is my 200.
Should have taught us this last year.
You weren't ready yet.
I was.
Okay, we need to find those 2 points because I'm trying to find when my height is greater. So would you agree that my height is over 200 in between those two x values? Okay. If you just do trace on your calculator, it is not exact. So what I want you to do is hit second and then the trace menu. This takes you into your calculate menu. This is all the things your calculator can find for you. I want where two graphs touch. What do you think that is? Intersect, number 5. Okay, now your calculator is going to ask you some questions. Is everybody to this point? Okay. First curve. Your calculator will do this automatically, so all you need to do is hit enter. Second curve, it'll go ahead and jump to the second one. So once again, you can just hit enter. Now it's asking you for a guess. You need to move your cursor until it's close to the point you're looking for. So I'm just looking for the first one, so I'm moving my cursor over there, and then I hit enter. And it tells me exactly my x value is 1.39. Is that what you guys got? Okay, what'd you have to do to adjust your Y values so you could see the whole thing?
I had to go to trace. I just clicked some trace, yeah.
Okay, let me see it. I may have figured it out.
I think I figured out what that.
Nope. Both of those points to get the second one, we have to repeat. Did everybody get the first one? Okay. So we're going to go second, trace, intersect. First curve, you just hit enter. Second curve, you hit enter. But for your guess, this time move over to the right-hand point. Hit enter. And that one is 5.696. Is that right?
I got 6 zeros, yeah.
60. Okay, mine is super blurry up there, so I'm having 5.606. You said. So 5.61. So it's in between those two time frames that your height is over 200.
Would 5.7 be too close?
Probably just a little bit.
Isn't it? I think I'll still go first with it.
Yeah. So just hit enter, enter. Okay. After. Yes. Part D. After how many seconds will it hit the ground? So if it hits the ground, what's your height? 0. So we have two options. We could work this out by hand. What was this? 112 t plus 75. So you could work this out. If it factored nicely, you could do Box method, you could do quadratic formula. We've solved these things before. The other option would be to find it on our calculator. Okay? Let's talk about on our calculator. There are a couple different ways to do this. I think the easiest is for us to do it the same way we did this problem. So let's go to y equals. This time, what do I want my y2 to be? 0. So change your y2 to 0 because that's your second height. And then you graph it. So there's my parabola. My height equals 0, it's just the x-axis. We are looking for that point where it hits the ground, where it touches the x-axis. So then you can do the same thing we just got done doing. Second, trace, intersect. First curve, hit enter. Second curve, hit enter. Guess, get close to that point over there. And you get 7.615. So 7.262 seconds. Is that right? I think mine says 7.62. Like I said, it's super blurry. I can't hardly read it. But.
I just wanted to know some people.
Happy to oblige. A toy rocket is launched straight up from the top of a building 50 feet tall at an initial velocity of 200 feet per second. Alright, so part A, give the function that describes the height in terms of time t. So what would we do? My height function is negative 16t squared plus v sub 0. What's my initial velocity? 200t plus h sub 0. What's your beginning height? Part B. Determine the time at which the rocket reaches its maximum height and the maximum height in feet. So what do I need to do? I didn't type this one, I just have it. I had it ready just in case. You know I'm always prepared. Always, always. So what do I need to do? You could graph it or do opposite of b over 2a, couldn't you? Because I'm just looking for the maximum. So that would be negative 200 over 2 times negative 16. We get 6.25, that would be my seconds. So then how did we find the maximum height? Plug that in for t. I'm not going to write all that out, but I'm just plugging it into this equation. We got 675 feet. So that would be our maximum. Okay. Part C. For what time interval will the rocket be more than 300 feet above ground? What are we going to do? Right. So, get your calculator. Y equals, the first one is negative 16x squared plus 200x plus 50. Second one, I want my second height to be 300. Let's go to our window. Right now my Y max is 275. Is that high enough to see what I need? No. So let's just make it 325. It's got to be bigger than the 300. Now, will this show me the maximum point? No. If you wanted to see that actual vertex, you'd have to go higher because we know our maximum happened at 675. But this should show me enough. Now, I'm seeing this first point, but am I seeing the second one? So what do I need to change? Your x max. So I need to see more x's. Let's go up to 20. 200 is probably a little big. Okay, did that show me enough for what I need? Yeah, I just need to find these 2 points. So how do we do those? Second, trace, intersect. First curve hit enter, second curve hit enter, guess. Let's get over by the first point. And my calculator just froze. The one on the computer has a lot of bugs in it, so sometimes it crashes my whole computer when I use it. Alright, so we got 1.41. Okay, so now the second one, so just repeat. Second, trace, intersect. First curve enter, second curve enter, guess. Now you got to move all the way over by the right. And I get 11.09. So that is our stopping point. You guys had some problems yesterday. Do I need to write those back down, or you guys also have them? Yes.